Okay, next we're going to look at example 3 and example 4 of lesson 3. And we're going to practice expanding and condensing logs using the properties of logarithms. Okay, in problem number 9, we are going to expand each expression. That means we are going to break this logarithm apart into multiple logs. Okay, now in this expression, we have 4 times n to the third power times n to the fifth power. Every single term that we are multiplying together, we can break apart with addition using the product property. So I'm going to rewrite this as the natural log of 4 plus the natural log of n to the third power plus the natural log of n to the fifth power. Okay, so each term being multiplied is its own separate log separated by addition. To finish, when we expand a log, we cannot have any powers in the expressions that follow the logs. So any power, we're going to use the product property and move the power out front of the log. Okay, so if I look at my problem, I'm going to keep natural log of 4 plus, now the second logarithm has m to the third power. So I'm going to use the power product and move the 3 in front of the log. So we have 3 natural log m plus natural log of n to the fifth power. We're going to take the power, move it out front using the power property. And this is 5 times the natural log of n. Okay. We have completely expanded the logarithm, and this represents my final answer. In problem number 10, we have log 2x minus 3 divided by 3 times the fourth root of x. Okay, this is a single log and we're using division. So we're going to use the quotient property to separate the numerator and the denominator into 2 separate logs. Using the quotient property, we separate them by subtracting. So we have log. Now we're going to take each expression, or the expression in the numerator, since there's more than one term, and put it in parentheses. So we have log 2x minus 3. Okay, minus, and we have the log of 3 times the fourth root of x. Now, I can't change anything with log 2x minus 3 because that is one expression. Now, with the log 3 times the fourth root of x, I am multiplying 3 times the fourth root of x. So I'm going to expand that using the product property, separating the 3 and the fourth root of x with addition. So we have log of 3 plus log fourth root of x. Now, I cannot have radicals within logs, so I'm going to rewrite the fourth root of x as x to the 1/4 power. So this is the log of 2x minus 3 minus, and I have log 3 plus log x to the 1/4 power. Okay, I cannot have radicals, but I also cannot have powers. So now I'm going to use the power property to move the 1/4 in front of the log. So this is equal to the log of 2x minus 3 minus, and within this quantity I have log 3 plus 1/4 log x. To finish expanding, I have to distribute the negative to both terms within the quantity. So I need to distribute -1 to log 3 and 1/4 log x. So my final solution is log 2x minus 3 minus log 3 minus 1/4 log x. example 4, I'm going to condense each expression. So in these examples, I have expressions written as multiple logs, and I'm going to rewrite these expressions as a single logarithm. Okay, in problem number 11, I have numbers 1/2 and 3 both in front of the logs. So I'm going to use the power property to move those to the power of the expression. So I'm going to rewrite this as log base 4 of x to the 1/2 power minus log base 4 of x minus 2 to the 3rd power. Now, x to the 1/2 power is the same thing as the square root of x. So I'm going to rewrite this as log base 4 times the square root of x minus log base 4 of x minus 2 to the 3rd power. Okay. Now that I have the logs by themselves somewhat simplified, I'm going to combine this as a single log. Since I'm subtracting, I can combine this using division. So I'm going to have a single log, log base 4, and my numerator is the square root of x, and then my denominator is x minus 2 raised to the 3rd power. Once you have this written as a single logarithm, you are finished. Okay, let's go down and try number 13. Okay, in problem number 13, I have the natural log 3x plus 5 minus 4 natural log x minus natural log x minus 1. When I see that I have two negatives, I'm going to factor out a -1. So this is equal to the natural log of 3x plus 5. Now, if I factor out a -1, then that's going to leave me in parentheses with 4 natural log x plus natural log of x minus 1. Okay. Now, 4 natural log x, I'm going to use the power property to move the 4 to the power. So this is equal to the natural log 3x plus 5 minus, I have a natural log of x to the 4th plus natural log of x minus 1. Okay, just like order of operations, I'm going to work within the parentheses first. Okay, I have two logs with the same base and I am adding them. I'm going to combine those as a single log using the product property, which means I'm going to multiply x to the 4th power and x minus 1. Okay, so as a single log, this is the natural log, x to the 4th times the quantity x minus 1. And I do not need parentheses around this anymore. Now I have two logs separated by subtraction. I'm going to combine these as a single log using the quotient property. So I have natural log. Okay, there's my fraction bar. The numerator is 3x plus 5. The denominator is x to the 4th power times the quantity x minus 1. And I have simplified this log to a single logarithm. Okay, I'm going to have you try problem number 12. So go ahead and pause the video and attempt to condense the expression. When you have finished, hit play and I'll walk through the problem so you can check your answer. For problem number 12, I want to write this expression as a single log. I notice that both logs have a number out front, so I'm going to use the power property to move those numbers to the power. So I'm going to rewrite this as the natural log of x plus 1 raised to the 5th power plus the natural log of x to the 6th power. Now I'm adding these two logs together, so I'm going to use the product property to combine it as a single log. And I can do that by multiplying the two expressions together. And I'm going to put the monomial first. That's x to the 6th power times the quantity x plus 1 raised to the 5th power. You do not need to distribute x to the 6th or multiply out x plus 1 raised to the 5th power. You can keep it just the product of those two terms. Okay, last example is example 5. Use the change of base formula to evaluate each logarithm. Okay, the change of base formula is the following. Okay, we have log base b of x is equal to the log base a of x divided by log base a of b. Okay. Now, typically, we're going to use each of the following on the right. For natural logs, okay, log base b of x is equal to the natural log of x divided by the natural log of b. Or if we have log base b of x, this is equal to the log of x divided by the log of b. Okay, we use the change of base formula when we need to simplify a logarithmic expression involving values that we cannot calculate by hand. So if you look on your calculator only has the common log and the natural log. So we cannot calculate log base 4 or log base 6 on your calculator. Okay, but what happens, or what do we do when we have logs that we can't simplify by hand? Well, we're going to use the change of base formula to get approximate values. Okay. So if I look at example 5, it says use the change of base formula to evaluate each logarithm. Okay. So again, change of base formula, I'll write it out here. I have log, oops, I need a different color. Log base b of x. This is equal to the log of x divided by log b. Notice both of those are the common log, which we do have on our calculator. So in problem number 14, I want to calculate log base 6 of 4. Now again, if I were to calculate this by hand, it'd be 6 to what power is equal to 4? Well, I can't do that by hand. So I'm going to use the change of base formula. So this is the log of 4 divided by log 6. Okay, plug this into your calculator. So I have log of 4, close your parentheses, divide that by log 6, close your parentheses, and it is approximately 0.774. Okay, in problem number 15, we have log base 1/3 equal to 8. Okay, so again, this would be 1/3 to what power is equal to 8. I cannot calculate this by hand, so I'm going to use the change of base formula. So I'm going to say log of 8 divided by log of 1/3. And I'm going to plug this into my calculator. Okay, so when I plug this in, I'm going to go log 8, close my parentheses, divided by log, 1/3, a fraction is division, so I'm going to go 1 divided by 3, close my parentheses, and this is equal to approximately negative 1.893. Now, it doesn't matter if you choose to use the common log or the natural log. So we could have used the natural log and made this natural log of 8 divided by natural log of 1/3. If you plug that in your calculator, you're going to see that we get the same answer. So natural log 8, close your parentheses, divided by natural log of 1/3. And you can see we get the same answer. So whether you use common log for the change of base formula or the natural log, it's completely your preference. Okay, I'm going to have you try some problems out of the textbook. Okay, answers will be posted in Canvas. Make sure you write down questions that you may have that I can answer in class. Good luck.